Okay, we're going to look at now are called series, and what series are is the summation of a sequence, right? When you talk about a series, you're usually talking about adding up all the numbers or multiplying up all the and adding up all the values of each of the numbers. Okay, so what's very common here, and what you should all be used to, whether you're taking, particularly if you're taking statistics or especially calculus. Um, but what this is a sigma notation. What this means is we are going to add up numbers. Okay, it means we're going to add up numbers, but we need to generate these numbers first. Okay, and what we're going to do here is we're going to start at one, and then there are one, two, three, four, five, six numbers. So we're going to add up six numbers. And what we need to do is we're going to write the formula which generates those numbers. Okay, so first of all, we want to figure out, well, what is this? We know each time we are adding 10, adding 10, adding 10, adding 10. So our common difference here is 10. So think about it like slope. So if our common difference is 10, okay, we need to find the b value, or where does it start? So a simple way to kind of figure this out is, number one, we're multiplying by 10 each time, so the common difference is going to go there. And what I like to use with arithmetic sequences is, what is the ghost term? If there were a term that were right here, what would that term be? And if so, if you do 7 minus 10, if we go in the other direction, we're going to get negative 3. Okay, so that's a simple way to kind of come up with the arithmetic series. Because what we're doing is we're just taking what we know, the common difference, which is 10, and then we're just going back one more to find, well, what would the ghost term be? What would that term be right before the number? Okay, so how does this work? Well, let's plug it in. 10 times 1 is 10 minus 3 is 7. 10 times 2 is 20. 20 minus 3 is 17. 10 times 3 is 30. 30 minus 3 is 27. So you can see how it generates this all the way up to the last term, all the way up to 6. So 10 times 6 minus 3 is 57. So that's how you get that. And then all you do here is add up all those numbers, and that's what the sigma notation means there. Okay, so that's how you write a formula for a sigma notation here. Okay, now again, working with some formulas, we're going to be working with a lot of formulas here. You can see here, if I find the sum of the first 36 terms of the following. Okay, so I've got number one, two, three, I've got three terms here. So what's happening each time, you can hopefully tell. If I do 15 minus 9, I'm going to get 6, and then 15 plus 6 is 21, so I've got it, right? I've got what is going to make the difference between those numbers, right? All right, I also have the first term. So let's look at our formula. This is the sum formula. This is going to show us how to add them all up. All right, our number is 36. We know our first term is 9. What we don't know is the 36th term, and we're dividing by 2. Okay, so what we need to do is figure out, well, what's the 36th term of this function? Okay, so if I'm going to find a of sub 36, okay, I'm going to take the first term, which is 9, plus 36 minus 1 times the difference, right? And our common difference here, we figured it out, was 6, so I'm going to type 6 in right here. So now we're going to get, well, the 36th term is 9 plus 35 times 6. And then if you go ahead and do that in our calculator, all right, we're going to do 9 plus 35 times 6. We're going to get 219. All right, so I know that the 36th term is 219. So I'm going to put 219 right in there. Okay, so if I want to find the sum of the 36 terms, I'm going to get 36 times 9 plus 219 is 228, all divided by 2. So let's go ahead and do that in our calculator. I've got 9 times, wait, what was it? I got to go back here. 36 times 228 divided by 2. All right, so 36 times 228 divided by 2 and then I'll come up with a solution of 4,104. And what that means is if I add up all these terms, I'm going to get 4,104 as my number. Okay, so you're going to see that there's two formulas we're going to have to practice using. This formula right here is a sum formula, and this will help you find the number term that you are looking for. So if I'm looking for 36, you're going to use that formula. Okay, that is called an explicit formula. Now, what happens over here when we are now dealing with a geometric sequence? You can see right here, what happens is that we are multiplying by 3 each time. If you're not sure, do 42 divided by 14 in your calculator, and you're going to get 3. And then just double check that 42 times 3 is 126, and it is. So I know that the common ratio is 3. So let's see what we can figure out here. We're going to find the sum of the first 9 terms. I know the first term is 14. And now I'm going to substitute in what I know. 1 minus, I know the rate is 3. I know I'm looking for 9. So that's raised to the 9th power. All over 1 minus the rate. And the ratio is 3. Okay? So on our calculator, right, we're going to evaluate this first. I'm going to do 14 times, what is 1 minus 3 to the 9? So 1 minus 3 raised to the 9th power is that number, negative 19,682. All right, so negative 19,682, all divided by negative 2. So if I'm going ahead and do that on the calculator, you can see here, I'm just going to multiply by, was it 14? Right, yeah, multiply by 14. And then divide by negative 2, and I'm going to couple it with an answer of 137,774. All right, so this is 137,774. Okay, that means if I multiply by 3 for 9 terms and then add them all up, I'm going to get a huge number, 137,774. Okay, so again, just learning how to use the geometric. This is the sum for geometric formulas. Okay, now if I go ahead and take a look at one more, really, we wanted to find the numerical answer to the summation given. Okay, and what this means is we're going to plug in 6. All right, so I'm going to say 3 times 6 plus 4, 3 times 7 plus 4, 3 times 8 plus 4, all the way up to 3 times 83 plus 4, and then I'm going to take all of those numbers and add them up. Okay, so that's very hard to do if you want to do it by hand. It's not hard, it's just going to take a long time. So what we're going to use is the summation formula. So the summation formula says we're going to take the sum of 83 terms. So that means I'm going to do 83 terms. Now I know what the first one is. 3 times 6 is 18 plus 4 is 22. So I figured out the 22. Okay. I don't know the last term, and I'm going to divide by 2. So how do we find the last term here? How do we find the last term? Well, that's pretty easy. I just substitute in 83. So 3 times 83 plus 4. So let's check that out. What is 3 times 83 plus 4? Okay, 3 times 83 plus 4 is 253. So there we go. I know that this last term is 253. So now we use our calculator. 83 times 22 plus 253 is 275 divided by 2. So 83 times 275, and now divided by 2 is that, 11412. Wait, that seems wrong. Let's put that in there for now, and then we'll keep this video as is and see if you can determine my mistake. Okay? What did I get there? The answer should be 10,725. Okay, I got 11,412.5. 11,412.5. Okay? See if you can find my mistake there. Okay? And then you can see there's one more that I kind of wanted to show you here, is this one right here. And what we're looking at here is, oh, I know my mistake. Let's go back and fix my mistake. I know my mistake. We're not looking for 83 terms here. All right, so let's fix this. Okay, we're not looking for 83 terms because remember, we're starting at 6. Okay, and we're going to the 83. So how many terms do we really have? If I do 83 minus 6 and then add 1, I'm going to get 78. Okay, so we're actually looking for 78 terms. All right, but you're still going to generate the last term. So the sum of 78 terms, you can see you get a sum of 78 terms. And let's see if that gives us the answer. 78 times 275 divided by 2. We've got 78 times 275 divided by 2. There we go. All right, so that I realized my mistake right there. Okay, so be careful substituting in, right? We have 78 terms. From 6 to 83 are 78 terms, not 83 terms. Okay? All right, last little one I wanted to show you is what happens if we have an arithmetic sequence. And as you can see here, this is kind of dipping into our exponential growth and our applications that we've consistently been working on here. Okay? All right, so same idea here, right? If I'm starting at 1 and then I'm going to 63, it makes it a little bit easier because now we know we're definitely working with 63 terms. So I've got the sum of 63 terms. All right, now let's see what's the first term. Okay, so if I substitute in 1 right here, 1 minus 1 is 0. 1.112 to the 0th power is 1. And you know from our exponential functions, right, y equals ab raised to the x, a is going to be our first term. So I can substitute in here 90. And then I've got 1 minus, now what is the rate? The rate is 1.12 raised to the n, which means the number of numbers that we're looking for. We're looking for 63. Okay, and then I've got 1 minus the rate again, so that's 1.12. Okay, so this is a little tricky to do on your calculator. Okay, I would do the top and then the bottom, and let's figure it out. So I've got 90 times 1 minus 1.12 to the 63rd. All right, so I've got 90 times 1 minus 1.12 raised to the 63rd. And then I've got that ridiculous number. And then I'm going to divide by 1 minus 1.12, and that's going to give you your final answer, right? So we've got 945,044. We're just going to round to the nearest integer. So that's 94,544. What was it? 94, did I say? 945,044. So 945,044. Okay? Hope this helps. Good luck.